A point travels along the x-axis with a velocity whose projection v is presented as a function of time by the plot in the figure given below. We have to draw the displacement versus time graph and acceleration versus time graph. So if we understand this particular question, so there are different aspects to this particular question. So I am redrawing this velocity time graph, and then we will understand it in one by one way how to draw the acceleration versus time and displacement versus time graph. So from 0 to 1 second the velocity is rising, so we can say that it is an example of accelerated motion. From 1 second to 3 seconds the velocity is constant, and hence we say that acceleration will also become 0. After 3 seconds the velocity is constantly decreasing and it reaches -2 at 6 seconds. So we say that the acceleration is negative. So it is 1 second mark, it is 3 second, this is 4 second mark, this is 6 second. And from 6 second to 7 second, again the velocity starts rising and we say that the acceleration is positive. So it is 1 meter per second and this is -2 meter per second. So if we first of all plot the acceleration time graph, so till 1 second we are making the necessary points over here in the graph. To get a better understanding. So if we calculate the slope of the graph, we are getting 1 by 1. So over here in this portion, the slope of the graph is 1 by 1, or we can say that the acceleration is constant at 1 meter per second square. And now the velocity is constant, so the acceleration becomes 0 from 1 second to 3 seconds. Now in this portion from 3 second to 6 second, the acceleration can be calculated as 3 by 3, that is -1 meter per second square. The change in velocity over here is 3 boxes, 1, 2, 3, and over here is again we have 3 boxes, 1, 2, 3. So we can say it as 3 by 3, which is equals -1 meter per second square. So from 3 seconds to -6 seconds to 6 seconds, the acceleration is -1 meter per second square. Now in this 1 second, the velocity increased by 2. So we can say that acceleration from 6 seconds to 7 seconds is 2 meter per second square and is positive. So we can extend the graph a little to 2 meter per second square, and we say that between this 6 to 7 second the acceleration is 2 meter per second square. So this is how the graph is going to look like for the acceleration versus time graph. Now we are going to discuss about the displacement time graph. So I am removing acceleration time graph. We have already noted the certain acceleration which was needed for us to do the calculation. That is in this portion I am writing acceleration as +1 meter per second square, then acceleration is 0, and in this portion acceleration is -1 meter per second square, and in this portion acceleration is +2 meter per second square. So we are removing the acceleration time graph and making space for the displacement time graph. So now we will be understanding displacement time graph. So displacement can be written as the area under the graph. So till 4 seconds, from 0 to 4 seconds, the displacement is positive, the graph is in the positive portion, and we can calculate that the positive portion, the displacement is half, it is trapezium, so sum of parallel side into height, so we say it is equal to 3 meter. So the displacement in the positive portion is going to be 3 meter, and that is the maximum displacement of the particle which is possible. After which the graph is in the downward side, that is the displacement is decreasing for the next 3 seconds. And if I calculate from 4 seconds to 7 seconds, we can calculate displacement as half into 3 into 2. So we are going to get minus 3 meter. So basically I can say that the displacement time graph is going to begin from 0 and end at 0, because the total displacement is coming out to be 0. So we don't have to care about the negative aspect. The total displacement is starting from 0, and at 7 seconds the displacement time graph is again coming back to 0. But at different point the nature of the curve is going to be different. So this is the reason why we are going to be very observational about this particular question, because the velocity is playing its game in different times. So in this part the velocity is increasing, acceleration is constant, so I draw displacement time graph like this. Now from 1 second to 3 seconds the velocity is constant, so displacement time graph will be a linear graph like this. Now the velocity is decreasing and acceleration is negative, so the particle is going to follow a graph like this, and then the nature of the graph is going to come down like this till t equals 6 seconds. So in this part the displacement was still increasing while the particle was decreasing its speed. Once the speed becomes 0 over here, the particle changes its direction of motion and it starts coming back. So the displacement also starts decreasing from t equal to 4 second mark, and this is the point where the displacement is maximum, that is 3 meter. Now after 6 seconds the acceleration is positive but the velocity continues to be negative, so it is going to be a graph like this and the displacement becomes 0 at 7 second mark. So it is important to understand the nature of displacement time graph, which is constantly changing at different time intervals.